Talk about radiation and its effects. First effect is ionization, and ionization is the process by which an atom can generally make another atom lose electrons and become negative or positive by gaining or losing electrons. This can happen when you have a radiation particle or ray passing next to an atom of another isotope, and then it can collide with their electron and then move it away from its energy shell where it's deflected, and then by that the atom will lose some electrons and then it will be positively charged and become ionized. Yeah. When the atom is ionized, then the number of electrons has changed, and this is mostly by knocking one of the electrons in the outer shells. Okay. Now let's talk about different radiations and their ionization effects. So the first one is the alpha particles, and alpha particles, as we know, if they pass by an electron in the outer shell, because alpha particles are positively charged, they can attract this electron, and by attraction they will make the atom lose one electron and become ionized by electron loss. Beta particles, we know them as negatively charged, and because they are negatively charged, if they pass by an electron in the outer shell, they can repel that electron, and then by repulsion then they will lose one electron and then they will become ionized. Now let's talk about gamma rays. Since gamma rays are waves and they don't have any mass or charge, they carry no charge, their ionization of the atom cannot happen when they pass by from a distance. They need to have direct contact or encounter between electrons where they can ionize them. So if an electron is nearby a gamma ray and there is a collision or an encounter between one another, then there will be an ionization that will take place where the electron will be expelled or repelled, and then they will gain enough energy to leave the atom. Let's talk about the effect of the electric field on the radiation. So if we have a radiation coming through by the different negative and positive electric terminals, we know that those terminals will have an effect on the radiation passing through. So alpha particles, as we know them, they are positively charged, and then the beta particles are negatively charged. So when they pass, the negative charge will be attracted to the positive, and then the positive charge will be attracted to the negative terminal, while gamma will have no effect or no deflection. When we talk about the magnetic field, so the magnetic field and the radiation effect, so the magnetic field can be studied using the left-hand rule, where the source of the radiation or the alpha particles will act as the conventional current, using our middle finger to follow the direction for the conventional current or the source of radiation. And then the direction of the force will be following the alpha particles, so the alpha particles will be deflected in the direction of the force, so going vertically up in this scenario, and then for the beta particles they will go in the opposite direction of the alpha particles. Again, gamma rays, they don't have any deflection because they are not affected by the electric or the magnetic field. And one more note is that the beta particles have largest effect due to their lower mass when they pass by in electric field or magnetic field.